Hi everyone, I'm glad to present our work here at the EMNLP'23. Instructed language model with retriever are powerful entity linkers. I'm the first author of the link and currently a first-year PhD student at Rice University, and this work represents a new breakthrough in generative entity linking, achieved in collaboration with Microsoft. First, I would like to introduce you to the task we are dealing with. Entity linking refers to the process of identifying any possible entity dimensions and linking them to a large knowledge base, Wikipedia for example. This document is chosen from the test dataset, and I believe mentions in it are well-known terms for general audience. Generative entity linking aims to formulate the linking process as a text-to-text generation problem. During training, documents and post-processed output are treated as a training pair, where post-processing involves inserting special tokens into the document to indicate the correct linking results. And during inference, we only need to parse the output to get linking prediction. By applying constraint decoding, we can ensure that the output is always legal for regular expression to match the prediction results. However, this setup suffers from heavy inference latency, as at each time step we have to run the forward pass on large language models to decide whether we should start a mention here. We can see for a simple sentence like this, we have to call the language model for 64 times with a beam search of size 6. Here we present our retrieval-augmented framework for generative entity linking. This is a fast and compact solution. First, we train an external retriever on documents and entities in the documents, so that during inference, the top K retrieval will give possible entities in the document. Intuitively, we know that most tokens in the documents are unlikely to be mentions, so with the retrieved entities, we can get all possible mentions with which we can run simple matching between the document and the possible mentions, which we called surface form matching. As you can see, the document is now with underlined marks that indicates decision requires spans. The guided entity linking generation will follow these spans, skip any impossible tokens, and call the language models only when a decision is required. In this way, we successfully offload the mention detection responsibility to an external retriever. And also, in this example, we reduced the number of forward passes from 64 to 4. This makes it possible to realize real-time generative entity linking. Standing on the shoulder of modern foundation models such as Llama and GPT, combining with our novel linking strategy, we achieve superior evaluation results over out-of-domain dataset, and gain a 3 average F1 points over the previous discriminative competitors, and this number expanded to 6.7 when comparing with previous generative methods. Our paradigm also enjoys competitive data and compute efficiency. We surpass previous discriminative peer by a large margin with only 1/20th of the data, and we use only 1/10 of the training compute to beat previous generative method. We also run evaluations on the size and type of large language models, and observe some emerging ability starting from the size of 2.7. And OPT and Llama with similar model size still shows noticeable performance gap, indicating that the pre-training quality of the base model will also impact the generative model's linking performance. Last, we also investigate how well the general large language model handles entity linkings. To make a fair comparison, we gave the two variations of GPT 3.5 the exact same entity identifiers as we gave to our model, and see if it can correctly identify mentions and linking entities. Here in the example, it missed obvious mentions, that is Apple here. So, the evaluation on 4 test datasets are far from satisfactory, which confirms our concern that the entity linking still remains a hard problem for general large language model. And that's all of my presentation, and I look forward to seeing you in Singapore. Bye.